Hello everyone, welcome back to another video, and in this video we're going to be taking a look at a question from the HL paper 1, and this is from the May 2019 time zone 1 batch. Now this question is all to do with topic 6, which involves rates and reactions and stuff like that. So they're basically asking us which conditions are required for the reaction between two molecules, and they've given us 1, 2, and 3, and then they have given you ABCD. Now such questions, like this format of questions, is actually very easy to tackle if you're a bit unsure about the topic, right? If you do not know, if maybe you're a bit confused about what is two, would this be a correct option, you can always get down to the answer, or actually cancel out a few answers and narrow down your options so that you have a better chance at scoring good marks. So basically, the first thing you could do over here is that let's look at the first option, a collision. Is a collision required for between two molecules for a reaction to occur? Well, obviously, right? If you don't have a collision, how are they going to react with each other? You need some contact. You need some form of contact with them. You need them to bond, or you need them to break bonds, or something like that. You need some form of contact or connection, right? Otherwise, without that, a reaction happening between two molecules, it just doesn't make sense. So naturally, 1 is going to be the correct answer. And that means we can eliminate C because there is no 1 in C. So now we're left with A, B, and D. Okay. So 1, we agree. Now, what is this? What is this over here? What is E is greater than EA? What are these weird symbols, Now, EA, if you do not know, is actually activation energy. Now, what is activation energy? Well, activation energy is the minimum amount of energy required for there to be a successful collision between two molecules. By successful collision, what I mean is that when these two molecules, or whenever these two substances collide, in order for them to have or undergo a reaction, they must have sufficient energy. Not only should they collide, but they should also have sufficient energy to carry out the reaction once they collide. So that is basically activation energy. It's the minimum amount of energy required for a successful collision to happen. And E is nothing but energy. E is just energy, right? So they're saying that energy, in this case, by using this mathematical sum, they're saying that energy should be greater than or equal to activation energy. And well, yeah, that's true. That's correct. If you want a successful reaction to happen between two molecules, well, 1, you need them to collide, and 2, you need both of them to have either the minimum amount of energy or exceed the minimum amount of energy. Either ways, it's fine, but you need to exceed or at least meet the activation energy in order for a successful reaction to happen. So yes, we need 2 as well, and then we could automatically eliminate B because it doesn't involve 2. Let's look at the next part, proper orientation. Now at this part you may be a bit confused. What is proper orientation? Do we need this? Is it necessary? Because these are just molecules, right? Like, do we need proper orientation? And as a matter of fact, we actually do need a proper orientation. Without a proper orientation, a successful collision cannot happen. So see, supposing, right, it's kind of like a recipe. What is a recipe to create a reaction? Well, 1, you need them to collide. That's like the very first step. This is like the salt of your recipe, right? You absolutely need it. Like almost all savory foods or all dishes require salt. So this is your salt of your recipe. Collision, you need them to collide. That's like the very first, the basic step. 2, you need them to meet the activation energy, right? You need activation energy. You need this. Sorry. And the third one is they should not only collide and have the activation energy, but even the angle and the orientation that they collide in should be appropriate for the reaction to take place. Now, I'm going to give you an example, right? For all my biology students, this is probably going to be a good example for you because I'm a biology student myself, and there is no better example to explain proper orientation than a reaction between an enzyme and a substrate. So what is this? So for my non-biology students, and enzymes in our body basically help to catalyze biological reactions, right? They're catalysts. And For example, when you eat food, right now you've eaten a nice slice of pizza, and in that pizza you have a lot of carbohydrates. Of course, you have a lot of carbs in the pizza. So this is carbs. This is carbs. This is a carbohydrate. This is a carbohydrate that you've just ate, and you want to break this carbohydrate down so that your body can use it, because as you may know, your cells just can't use carbohydrates. You need to break it down into its monomeric units, or you need to break it down into its or you need to break it down into smaller pieces. You can't use carbs as a whole. Your cells can't use that. So to speed up the process, or to increase the speed of breaking down carbs, you have enzymes. This is an enzyme, right? And enzymes are catalysts. And this area, this little mouth over here, this is the place where this carbohydrate is going to go and fit. It's going to fit itself inside here. It's going to go and fit itself inside here. And then the enzyme is going to help to break the carbohydrates down. This is a very simple explanation, but this is basically what happens, right? Now imagine, right, if the carbohydrate wasn't coming at this angle. Imagine if the carbohydrate was coming at this angle. So suppose this is the enzyme here and the carbohydrate is here. This is the carb. Even though these both are going to collide, even though the carbohydrate and the enzyme are going to collide, and even though they both have the activation energy, there will be no reaction, because the active site, this area over here where the carbohydrate is supposed to fit, is called the active site, where the breaking down takes place. This is the active site. The active site is facing away from the carbohydrate. So even though these both are going to collide, nothing's going to happen. Even though they meet the energy, they have a collision, but the orientation is not correct, right? The orientation should have been here. The carbohydrate should be here. So that's why the orientation should be correct as well. So this is an important factor in a reaction to occur between two molecules. Now, obviously, this is a biological example, right? I cannot think of a more chemistry involved or a more IBDP chemistry example right now off the top of my head, but hopefully I've given you an idea about why orientation is important. So we can eliminate A as well, and that means that B is our correct answer. You need all three of these factors for a successful reaction to occur between two molecules, right? Hopefully my little biology example didn't confuse you too much and you've understood the concept. So let me just write proper orientation here as well. And this was a short video, quick short video, and I've given you the three recipe or the ingredients you need to create the recipe of a successful reaction between two molecules. And hopefully I've cleared up your concepts. I'll see you in another video with a brand new question. If you have any other questions regarding this concept, any other concept, feel free to reach out to me on my social media or give me an email, put it down in the comments below. I'll be more than happy to help you. Thank you so much for watching. I'll see you in another video with a brand new question. Goodbye.